Hello everybody, this is Tommy and welcome back to my weekly physics explainer video. Today we'll be going over problem number 15x, and it tells us to sketch the trajectory of a simple harmonic oscillator over the course of one period on the phase space plane. The y-axis is the velocity rescaled by the square root of half the mass. The x-axis is the position rescaled by the square root of half of the spring constant. We want to explain the trajectory on subsequent periods. So, since this is a simple harmonic oscillator, we will always end up back at the same position after each period. So it should look something like a circle, and this is the equation of a circle. It's also given that the y-axis is the velocity and the x-axis is the position. So if we were to take an equation that uses both of these, such as the energy equation, we could rewrite it to make it look more like the equation of a circle, where e will be the radius, or the square root of e will be the radius. This will be the y, and this will be the x, which is the position, and this is the velocity. So essentially what happens is, wait, hold on, I just lost my mouse for a second. All right, sorry. So essentially what starts out at like this point right here, imagine a spring has just been fully compressed with like a mass in front of it. Its velocity is 0 at the moment because it's changing directions, and it's about to bounce back like this. So that's what's like happening as it goes along the circle in this direction. When it reaches about here, it's going to be in its equilibrium position. So and then it passes that, and then it goes all the way to the most stretched state, where it will start to, as it continues, it will start to head back in the opposite direction, back to when it was compressed, and then it goes back to the equilibrium position, and then it continues on and it goes back to the initial compressed state. So if you were to just imagine this going over and repeating again, because there's no force to stop it or dampen it, then it would just continue on forever in this circle right here. For the second part, we need to sketch the trajectory for the same plane for a dampened harmonic oscillator over the course of many periods. So essentially what's going on here is like just assume that it starts out like around the same place, right? But imagine like a pendulum starting its swing from like the highest point of its arc, which we can kind of call like the amplitude. Then it will just go, but every time it goes through its cycle, it will swing less and less because there is a force that is decreasing the period and the amplitude. As you can see right here, as it goes in its cycles, the position is getting smaller, the amplitude is getting smaller, and we can also see the velocity getting smaller, and eventually it will just stop at its equilibrium position and not move at all, kind of like this. So that's pretty much it. That's pretty much it for this problem. Thank you.